Okay, good morning. Welcome to
FunMath number 59.
FunMath number 59. Today we're going to take a look at a problem from the challenge problem section. Actually not exactly the same problem, but kind of the same problem. From Art of Problem Solving's Intro to Number Theory book in the chapter on units digits. What are the possible units digits when perfect fourth powers are written in base 4? Okay, you're going to have to organize a lot of thoughts here. So what's a good first step on a problem like this?
Writing down some base 4 numbers. Or perfect fourth powers.
What do you think would be better to get a little get a handle on things?
Fourth powers.
Okay. Do you know some fourth powers?
Well, 16 is 2 to the 4th.
Okay.
81 is 3 to the 4th.
Okay.
I don't know what 4 to the 4th is.
See if you can figure it out, because you do know what it is.
It's 16. It's 256.
256.
5 to the 4th is 625.
Okay. Are there any other fourth powers that you know?
10 to the 4th is pretty easy.
Okay. Well, look at your chart here.
Yeah.
Are there any other ones that you know?
What do you mean? Any others that I know?
Are there any other fourth powers that you know?
Not really.
Really? Count for me. Count to 10 for me.
1, 2, 3.
Wait, what was that first thing you said?
1.
What? What number's that? Oh, hey, if you're going to make a list, sometimes it's easy to start at
1.
instead of
2.
because 1 is pretty easy, right?
Yeah.
Yeah. Okay, so we just learned something. When you count, sometimes you start at 1. Sometimes you start at 2. I don't know when. Okay, so now, what do you notice about these numbers? There's an interesting little pattern here.
Well,
Is this divisible by 4?
no.
Why not?
Because 1 isn't really divisible by anything except for 1.
Okay, what's the remainder when you divide by 4?
It's 0, remainder 1.
So the remainder is?
1.
1. Okay, is this divisible by 4?
Yes.
Why?
It's 4 squared.
Okay, is this divisible by 4?
No.
Why not?
Because it's odd.
Okay, what's the remainder when you divide by 4?
On this one, it's 20, remainder 1.
Right, all I'm asking about is the remainder.
Oh,
What's the
1.
remainder?
It's 1.
Okay, is this divisible by 4?
Yes. It says 4 to the 4th.
This is a head scratcher. Is 4 to the 4th divisible by 4? Yes, because
It says it right there.
it's 4 to the 4th, actually.
Yeah.
So what is this divided by 4? What's 4 to the 4th divided by 4?
It's... it's 4 to the... 4 to the 4th over 4.
Is?
4...
4 to the 4th over 4 equals?
It's 4 cubed.
4 cubed. Hey, so the remainder is?
Is
When you divide this by 4, the remainder is?
nothing. 0.
Sometimes called 0. 625. What's the remainder when you divide this by 4?
Probably 1, considering our pattern.
Okay, do you know the divisibility rule for 4?
It's the last 2 digits.
Okay.
So 624 is divisible by 4.
Yeah, so the remainder is 1. So we have an interesting pattern here. The remainder when you divide by 4 is 1, 0, 1, 0, 1. Let's look at 6 to the 4th. Is 6 to the 4th going to be divisible by 4? Well, 6 to the 4th equals 2 to the 4th times 3 to the 4th. And if I put a 4 on the bottom, what is 4?
4 is 2 squared.
4 is 2 squared. So 6 to the 4th over 4 equals 2 to the 4th times 3 to the 4th over 2 squared. Is this going to be an integer?
Yes, because you can just cancel it out with
Okay.
this.
And what does it equal, actually?
It's 2 squared times times 3 to the 4th.
Okay, so 6 to the 4th remainder when you divide by 4 is
0.
0. Now 7 to the 4th, it's not super easy to figure out what the remainder is, except this is 49 times 49. Okay. What would you guess if this pattern was going to continue? What would you guess the remainder was going to be?
Probably 1.
1. Okay. So, if this was a math contest problem and you were going to guess, what do you think the possible units digits are in base 4 when you write perfect fourth powers? What do you think the possible units digits are?
Could be still 1 or 0.
Ones and zeros. We don't seem to have anything that would leave a remainder of 2 base 4. I'll write it like this. And we don't seem to have anything that leaves a remainder of 3 base 4, which is interesting.
Yeah.
So there must be some pattern going on here, but we can't quite find it yet. But I'm going to leave it as a little bit of a mystery. The remainders are the last digits.
Yeah.
Okay. And it looks like all the even numbers are divisible by 4 when you take them to the 4th power.
Yeah.
And it looks like all the odd numbers leave a remainder of 1 when you take them to the 4th power and divide by 4. That's pretty interesting. So we have to figure out why that's true, but maybe we'll talk about that later. Okay?
Yep.